My dear friends, welcome to Rajshekar classes on applied data science with Python. This is lecture number 524. In this lecture, we will try to understand SGD algorithm, that is stochastic gradient descent algorithm. So we have seen in previous lecture that in linear regression, the gradient descent update function looks like this: wj plus 1 equal to wj minus r into sigma I equal to 1 to n minus 2xi into yi minus wj transpose xi. We have seen, since this summation has go through all the points when n is large, this takes a lot of time. We say this is the problem with applying gradient descent for machine learning applications, especially when the data set is large. When the data is large, there is a very nice solution. There is a very nice solution to this, which is called stochastic gradient descent algorithm, SGD. If I have to pick one algorithm which is the most important optimization algorithm in the whole of the machine learning, I will pick SGD. SGD is literally the most important optimization algorithm in machine learning. By the way, in machine learning, we use lots of algorithms. There are many algorithms. The most important one is SGD. Literally, it has become the cornerstone, the most important algorithm, the most important optimization algorithm is SGD. We saw gradient descent. We modify gradient descent slightly and make it SGD. In deep learning, people are modified SGD further and come up with many variations like Adam and Adograd. These all are variations. These all are variations of SGD, which are literally becomes the most important algorithm in machine learning today. SGD is as important as linear algebra to machine learning today. In this current modern world of machine learning, earlier it was not so much important, but today it is literally the most fundamental thing. Having said that, let's see what is SGD. Just let me explain this one. What it says. First one, this one is gradient descent. Which one is gradient descent? This first one is gradient descent. This one is gradient descent, isn't it? What SGD says? SGD says very intuitively, instead of using all of the points sigma I equal to 1 to k, say sigma I equal to 1 to n, instead of using all the points, just see here, instead of using all the points, here you are using I equal to 1 to n. Instead of using all the points sigma I equal to 1, let's just say you are using k points here. This is the basic difference between GD, gradient descent, and stochastic gradient descent. What is the basic difference? In this case, you have I equal to 1 to n. Here I equal to 1 to k, isn't it? That is the basic difference. Let's say wj plus 1 equal to, what is this? Wj plus 1 is equal to wj minus, this is sigma I equal to 1 to k. This point is important. Here it is I equal to 1 to n. Here it is I equal to 1 to k minus 2xi into yi minus wj transpose xi. Of course, k less than n. Of course, what we have done is we replace n. What we did here, we replace n. Which one we replaced? We replace n with k. Here you have n. This is replaced by k. We have replaced. What we have done here, what we have done is we replaced n with k. Instead of using all the points, pick a random set of k points. That's important. Pick a random set of, but instead of using all the points, here what we are doing, we are picking a random set of k points. Remember, k can also be 1 or k can be n. Pick a random set of k points and do this update. And if you do this enough number of times, if you do this update enough number of times, enough number of times, the solution that you get W star with GD with W star with GD is same as W star with SGD. Of course, there are some mathematical conditions under which this W star GD equal to W star SGD always is true. There must be some mathematical condition. Don't worry about deep mathematical proof of it. What it says, if you pick k points randomly from the total data set of n points, if you do the summation over k points such that k could be anything from 1 to n. Let's assume n equal to 1 million. 1 million means 10 lakhs, let me say. You could take k equal to 1 or 100 or 10,000 or 1 lakh. Any number is alright. We will come to a special case here. For all it says, if you keep doing iteration, the solution that you will get with gradient descent is the same solution that you will get with stochastic gradient descent. This is called stochastic because stochastic basically means probabilistic, or wherever you use randomization. Here we are using random set of points. That's important. Here we are using random set of points, and hence it is called stochastic gradient descent. Now your question could be, let's assume we are using gradient descent, and let's assume I need 100 iterations. Let me say I need 100 iterations. Suppose I need 100 iterations to converge or to obtain X star using stochastic gradient descent. Suppose, let's say n equal to 1 million. Let's say n equal to 1 million. Let's assume your k equal to let me say 1000, isn't it? Yes. Let me assume n equal to 1000, and let's assume I need 100 iterations to converge X star. That is about GD. What about SGD? Suppose k equal to 1000 in stochastic gradient descent. Probably you reach X star in more than 100 iterations. That's important. Here we are in the case of gradient descent, we were assuming 100. We were assuming that 100 iterations. Where in the case of SGD, I will repeat, in stochastic gradient, probability you reach X star in more than 100 iterations to converge X star. Let's assume we need 500 iterations. If you perform SGD with k equal to 10, you probably require 1000 iterations to reach X star. What is my k? K is number of random points that you pick in each iteration for updating. That is important. What is k? K is number of random points that you pick in each iteration for updating. Remember, the set of k points that you pick for first iteration will be different for set of k points that you pick for second iteration. Isn't it? That's important. I will repeat. You remember, the set of k points that you pick for first iteration will be different for set of k points that you pick for second iteration. You need to pick these random set of k points every time for every iteration. The one that you use for wj to wj plus 1, the one that you use for wj to wj plus 1, and to go from wj plus 1 to wj plus 2, we will use a different set of k points. That is important. That's very important. But don't use same k points. We have to choose different. We have to choose random points. We have to choose the set of random points at every update or at every iteration. So the interesting part here is k is often called, what is this? K is often called batch size, isn't it? K, there is another name people used to call that k as, you can say it is k is I can say it's a batch size, isn't it? SGD is the most important optimization algorithm in whole of the machine learning. In modern machine learning, extremely important. It is very simple. It basically adding randomness or stochastic to picking up k points at a time, every iteration. It is very simple and very elegant algorithm. I request all of you to go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.